So chapter 3 introduces us to the idea of the phases of the moon. So as the moon goes around the earth, if we imagine the sun is off that way somewhere, then as the moon goes around the earth, then we have new moon, we have full moon, and so forth. So the moon going around the earth gives rise to the phases. It takes about a month for the moon to go around, and so that gives us the idea that we have a way of keeping track of time. That introduces a key part of the calendar. Now, I talked about calendars here. That's really a chapter 2 topic. The book only spends about a page on calendars, which I think is kind of not all that great, because I think it's really cool how calendars work. But I expanded on that. Hopefully you found that as interesting as I did. But we get back to the moon. And we said, wait a minute, if the moon is going around the earth, if the sun's off that way and we get new moon, wouldn't the shadow of the moon fall on earth? And at full moon, if the moon's over here, wouldn't earth's shadow fall on the moon? And so that would give rise to the idea of an eclipse. And so, in fact, that's where eclipses come from. And so when we're talking about the moon, then one of the things we look at is the motion of the moon around the earth. And so yes, the moon, it does go around the earth here, okay, but the orbit of the moon around the earth is tilted by about 5 degrees from the ecliptic. So about 5-degree tilt off of the ecliptic. And so that means that most of the time, the shadow of the moon misses Earth. And so you do not necessarily get a solar eclipse every time there's a new moon. Now, the only time you can get a solar eclipse is a new moon, but it's not every new moon. Okay, so what happens, though, is the tilt of the moon's orbit turns out to be such that it goes around, and the tilt stays fairly constant, pointing in one direction in space. So at a certain time of the year, then the shadow of the moon would hit Earth, or if the moon was a full moon, the shadow of the Earth would hit the moon. In that case, we could get a solar eclipse or a lunar eclipse. But a few months later, it's going to happen that the shadows miss one another. And so now there's no eclipse. And then eventually, half an orbit later, we get a period of time in which it's possible to get an eclipse again. So at new moon or full moon. So then the shadows hit each other. Now, the orbit precesses a little bit, and it precesses a lot more quickly than the rotation does. And so that means that these periods of time when they line up are not exactly 6 months apart. They're a little bit less than 6 months apart. That means that in a little bit less than 6 months after they're lined up again. So if you get a new moon or a full moon close to when they're lined up, if it's exactly when they're lined up, the shadow of one hits right in the middle of the other. If it's close, the shadow of one hits the edge of the other. And so that could be an eclipse or a partial eclipse. And so what would happen is that for a few weeks here, twice a year, if you get a new moon or a full moon, you're going to get an eclipse. So we call those the eclipse seasons. Now, say for a few weeks, from new moon to full moon is just 2 weeks. So since the eclipse season lasts almost a month, then you pretty much guarantee you're going to get a new moon and a full moon. And so now they might not be perfectly lined up, so you might get a partial eclipse, but you will get some kind of eclipse, usually a couple of eclipses every eclipse season, and sometimes 3 eclipses in an eclipse season. So what we want to do is talk about a solar eclipse. So that will be the first thing we'll be talking about. And I'll start that actually with our next lecture.